So this is our template for concrete mix design reference to British Standard Method, but more specifically I'm referencing this template from BRE 2nd edition, and based on the guidebook we will be using the K value to calculate the strength margin and to get the target mean strength. We will also use this table, which is a modified one, which will calculate and provide us automatically the strength value with the corresponding water cement ratio. So instead of using this table and drawing the lines analyzing where is the water cement ratio for a certain target mean strength, we will be using this table to automate that process. And here also I will be using the latest reference for the combination of aggregates, or for the combined grading we have to use the latest one, BSEN 12620, with the guidance from PD 6682. So starting with, of course, let's say for example I have here some specification, a typical one. So here let us say we are required to provide C50 minimum cube compressive strength, C50. For just an information, the equivalent cylinder strength will be 40. So let us focus on C50 as the cube strength. Here the minimum cement content is 370. Water cement ratio for this example is 0.4. So let us write here maximum water cement ratio is 0.4 with minimum cement content of 370 kg per cubic. So moving on, let us write here the concrete grade C50 and the available cement strength class in the market. Let's say it's 42.5. It's very typical. Moving on, exposure class, let's say not specified, and the concrete element will be used for superstructure. The maximum size of aggregate, just click on this drop down list and select as per specification, let's say 20 mm. And for the slump value, reference to BSEN 206, you will find out this suggestion or specified consistency class from S1, which is 10 to 40 mm slump, up to S5 for greater than or equal to 220 mm. So for this example I will be using S4 160 to 200 mm, or you can just simply type whatever your required or suggested slump based on your project requirements. So moving on, let's say the temperature is 32 and we proceed with the specified characteristic strength. Let's write here C50. Here automatically you will notice that the target mean strength is 60.2 as a result of the calculation based on the K value, which is 1.28, equivalent to 10% defectives. Or what it means is we are accepting that there's a potential 10% defectives from the population of our cube samples. So the lower the value, the higher the percentage of defectives. So if I go for 2.33, it will be 1% defectives. We are very much, let's say, conservative in this value, but it will be good if you are starting, especially with the higher grade, and if the project is new to you and you believe you need to have more margin. So in this example, for C50, the calculated strength margin is 18.64 megapascal. So 50 plus 18.64 will be 68.6, and our air content is 2%, so it will not affect the modified target mean strength. By the way, for every 1% air entrained, it will be equivalent to 5.5% strength reduction from the original target mean strength. So now going to the water cement ratio. As you can see, our strength is very low, 18.1. Since our water cement ratio is 0.9 here, I just make it an exaggeration so that you can see the difference by moving on this button up to, of course, less than the maximum 0.4 water cement ratio. We have to be less than that value. So if we keep pushing this button lower than the 0.4, you can see that this is slowly covering the target mean strength, which is the 68.6. So either we are higher than the target mean strength or at least equivalent. So we can say 0.35. And here also simultaneously you can see that the data is moving here upward as a trend of compressive strength. So based on the compressive strength with an equivalent of water cement ratio, you can see it also from this chart, the modified chart. So question, how do I know that the 0.35 water cement ratio will provide me 70.3 greater than the target mean strength? So we just have to go back to the reference. This is the reference of the guidebook. So we will start from the cement strength class, which is 42.5. The aggregates that I use is crushed. The strength at 28 days is specified, and according to this table, using water cement ratio of 0.5, it will provide us 49 megapascal using this cement strength class 42.5. So next will be the use of this figure 4, the relationship between compressive strength and the free water cement ratio. So first we have to begin with the 49 compressive strength, somewhere here just below this 50. So 49 coming from this table, this is the 49 megapascal strength, and this is the benchmark, you can say, starting line using data from table 2. This is the 0.5 water cement ratio. Next step will be creating a new curve line. So we just have to drag it down here. I made it before the presentation, I mean, so it will save our time. So here you can see it intersects the 49 with a new curve line. So next we have to draw again new line. Let's keep it here, 70.3. So let us say it's sitting somewhere here as 70.3, or you can say 70 megapascal. And next thing is we have to draw also another line, just intersect with the new curve line, and going down here you will see the new water cement ratio, approximately 0.35, equivalent here 0.35. So that confirms that this table will provide us the correct result as per the guidebook. But of course, the benefit for us is it become much easier, and we save time, and it's, of course, it's more practical and easy to do. So next will be regarding the cement content, starting with the 370 minimum. So let's write here 370. So what you notice here is the one parameter, I call it paste plus air over voids or aggregate voids by percentage. So what it does is showing us the percentage covering the aggregate voids. So paste plus air is only 97%. For pumpability, I recommend greater than or equal to, or at least 110%. So to do that, I have to increase this cement content. So using this button again, we will slowly increase the cement content. So let's say around 420. So let me just share to you the value of using this parameter paste plus air over percentage of aggregate voids, especially for pumpable concrete mix. Here, let us say if I start with 370, when I was starting during the early age in ready mix concrete, so I was thinking how to know whether I'm using insufficient amount of cement or if it's too much cement. So how do I measure that? Each parameter will tell me or will guide me that I am using a sufficient amount of cement, and that I can see actually the effect during the batching or trial mix in actual scenario. To do that, this thing helps me a lot. So imagine the 97%. I can guarantee you that if you try this one, you will see the difference between 97% and 110%. So for 120 kg, you will see the cement paste is covering all these aggregates and providing you sufficient amount of paste so that it will lubricate the concrete itself during the pumping process. So for pumpable mixes, for higher slump mixes, this will help you to optimize the amount of cement. So I hope that clarifies the matter regarding this parameter, and I hope also it will help you in practical use of this template. So next, here for 120 kg is the SEM1 or the OPC. For the normal or common term that we use, we call it OPC, but actually as per BSE and 197, this is SEM1 with 42.5 N strength cement class. This is the water, and let's say I will be using mid-range PCE 6 kg, around 1.3%. That will be a good starting point. It could be plus or minus during the actual trials. You can then just adjust it later on. So here you will notice that, of course, if you watch my previous video, I always include or deduct the percentage of water content within this admixture. So it is 4.7 kg, 78.7% of water within this 6 kg of admixture. So it will be deducted, and you will notice that the water now is 142.3 comparing to the original 147, since I deduct an amount of 4.7 water inside this admixture. So I hope that is clear to you. Next will be the aggregates. This is our proportion. So here I choose 36% for 20 mm, 18% for 10 mm, 46% for the 4 mm natural sand, with of course an equivalent of 100%. So as per the guidebook, it recommends the ratio of 1:2 between the 10 and 20 mm. So approximately 18% towards the 36% is 1:2 by ratio. Of course, you can adjust it according to the result of your trials. It's just an estimation. And here also, let me explain to you. This column refers to the SSD weight. This is the weight of the coarse aggregate and the fine aggregate in SSD condition or saturated surface dry condition, whereas here dry batch weight in this column, the aggregates here are in dry condition. So the water here again will be increased, as you noticed, simply because I have to absorb 10.1 kg of water. That is the summation of all the water absorption in percentage. You multiply with the dry weights of these aggregates. So this is the amount of water we have to absorb to make it saturate. So I need 10.1 kg, but I have to deduct 4.7 kg of water from this admixture. So I have total of 152.4 kg of water if I will have to batch this material dry condition of the aggregates. So if I sum all this material, it will be equal to 2524.86, which is also equivalent to 2525 if we round it off, meaning this equation is correct with regards to correction of water absorption and moisture. Next, here is the third section, aggregate grading and combination. So of course you have to update the SIB analysis for these aggregates for the 20, 10 and the natural sand I mean. So update all this SIB analysis, the percentage passing these SIB sizes. So these are the result of combined grading. This is just a summation of the factors between the, for example, this SIB number 100% for the 20 mm, 100% multiplied by whatever percentage or proportion of this combination. So 100% multiplied by 36% plus next value 100% of 18%, 100% of 46%, and so on. And that will equate to these values, and it will be plotted here in this combined grading. So this is the limits, the lower limit and the upper limit. Say for example, for the 20 mm SIB, lower limit is 90% and upper limit is 99%. We get combined the grading of 96%, so we are in the limit. The same goes here, 50 to 90, we get 63.6. Here for the 2 mm, 20 to 60, I get 43%. And this is our combined grading chart, so that it will be more visible for us and it will be good for our presentation. So this is how we create the mix design using this template. Very simple, straightforward, and it saves time. And of course you can expect that the target mean strength according to your water cement ratio will be achieved, and you will have the sufficient or optimized amount of cement content. So I really recommend this template. This will be very useful, and you can reduce the amount of your guesswork, as I've always discussed, using these amazing templates. Probably you can do 1 or 2 trials and you will find out. But for as long as you are using, of course, the materials conforming to a certain standard. Otherwise you have to create your own strength and water cement ratio chart. Just as I told you before, if you go to a certain location where the aggregates, for example, or cement is at different scale of its quality, maybe you can still use, but you have to establish your own chart so that you can at least estimate it more precisely according to the actual strength of your materials and according to the performance of your plant and your team. So this will always reflect on the actual scenario. So thank you guys for watching. I hope it helps you, and good luck to your journey to ready-mix concrete industry. Bye bye for now.